Hi, this is Kumar, and today we are going to discuss chemistry. Topic name is some basic concepts of chemistry. So today's our topic is atomic mass. Okay, so atomic mass is the mass of an atom, that is called as atomic mass. Okay, and if we discuss further, the mass represented by an atom, a mass possessed by an atom, is called atomic mass, and that will be the sum of all their constituent particles mass. Okay, so we can write the mass of an atom is called atomic mass. Okay, and atomic mass is the sum of their constituent particles. Suppose an atom have one electron, one proton. Okay, so its mass represented by the sum of mass of proton and mass of electron. If there is a neutron present, then we can add upon mass of neutron also. Okay, but atom is very small constituency. We can say atom is a very small particle, so its actual mass is very small. Okay, so we can write, since atom are very small, so consequently actual mass of an atom is very small. For example, actual mass of one atom of hydrogen is actual mass of one atom of hydrogen is equals to 1.673 into 10 raised to power 24 gram. So this is the very small mass. Okay, so that's why all atoms and their atomic mass are very small, and they come in every time in fractions because they are relatively very small. That's why we used for our convenience relative atomic mass, which we can discuss further. Okay, so we can say that thus for convenience relative atomic mass is used. Okay, so further, if we classify atomic mass, so we can categorize it in two categories. That is, first one, absolute atomic mass, or we can say that absolute atomic mass is actual atomic mass. Actual atomic mass. And second one is relative atomic mass. Okay, so if we talk about the absolute atomic mass or actual atomic mass, it means the mass possessed by an atom. Okay, so we can write it, the mass possessed by an atom is called absolute atomic mass, or we can say that it is the actual atomic mass. So if we talk the example of actual atomic mass, so actual atomic mass of carbon 12 atom, so we can write examples. Actual atomic mass of a carbon 12 atom is equals to 1.99 into 10 raised to power 23 gram. Means one atom of carbon 12 is weighs 1.99 into 10 raised to power 23 gram. Similarly, if we talk about the hydrogen, so actual atomic mass, so actual atomic mass of a hydrogen atom is equals to 1.673 into 10 raised to power minus 24 gram. Okay, so both the masses which is possessed by the single atom of their constituent elements will be very small. Okay, so that's why for our convenience and our calculations and for memorize, we can use relative atomic mass. Okay, so next we are going to discuss relative atomic mass. So here next is relative atomic mass, which we can say that relative RAM. So relative atomic mass means, its name denotes it relate with someone's mass. Means we can use here a reference, and based on that reference we can compare the mass of all the elements. Okay, So we can write relative atomic mass is equals to absolute atomic mass. Here we can say actual atomic mass, which is divided by mass of reference element, divided by mass of reference element. Okay, or we can say reference atom. So here meaning of reference, which one we are going to compare. Okay, so let's take an example. If I have a duster and duster's weight is 100 gram, so this is the actual weight of a duster, that we can say this is the absolute mass of duster, or we can say this is the actual mass of duster. So this is the actual weight. If I compare the mass of duster with mass of chalk, okay, so mass of duster if compared by mass of chalk, it will be heavy than the weight of chalk. And if we compare the mass of duster in respect to mass of board, okay, so mass of board, yeah, or we can say mass of podium. So mass of podium is very high compared to mass of duster. So in this case it will become a lighter than the mass of podium and mass of board. So in both cases, if we change the reference, the mass of duster will change. So its relative mass always depends on reference. Okay, so let's talk the reference. So in case of atomic mass, or we can say relative atomic mass, we used hydrogen as a reference element. Okay, so hydrogen was used that time as a reference to calculate the mass of all the elements. So we can write first reference is hydrogen so hydrogen as a reference suggested by Dalton, and we are talking here 1H1 or protium. So why hydrogen taken as a reference at that time? Because the mass of hydrogen is very light. Okay, and that time we can use is at a one, we can use the one yes, this is a unit mass of hydrogen. So we can write mass of hydrogen taken as 1 because it was lightest element. Then why it fails, why we can't continue the hydrogen's mass as a reference element? So that is the answer is by doing so the atomic masses of most of the elements came out to be fractional due to hydrogen has 3 stable hydrogen has 3 different isotopes, that is 1s1, 1s2 and 1s3. So if we are going to compare with 1h1, it will be okay with all the elements, but in case of the reference changed by 1h2 or 1h3, then it will be problematic. It will differ the mass of that elements, so we can't calculate actual, or we can say proper reference mass. Yeah, we can't calculate the relative atomic mass of that particular element. That's why we discontinue the hydrogen as a reference element. Okay, then the second reference, which is oxygen. So oxygen, this is 8O16 isotope taken as a reference element. So here oxygen is suggested by Ostwald. So this is suggested by Ostwald. Why we use it? Because it is suitable for most of elements, but it is not suitable for the rest of elements. That's why we discontinue oxygen as a reference element. So we can write it also not suitable for most of elements that came out to be fractional to be fractional due to it also has their stable isotopes that is O at 16, O at 17 and O at 18. And their relative proportion changes with time and with places. So we can write and their isotopes relative proportion changes with time and is different at different location so as a result the entire atomic mass will change. So as a result the entire atomic mass will change. Okay, that's why we discontinued it also. Now we come to the next, third reference. So third reference was used carbon. So third reference used carbon C12 isotopes. So carbon is suggested by Alfred Neher and A. Lender. So we can write this is suggested by Alfred. This is suggested by Alfred Neher and A. Lender in 1956. So carbon now using as a reference. So why carbon is used as a reference? Because it is widely used in mass spectroscopy as a standard element because it has zero mass defect. It has exactly the mass of carbon 12 is 12 AMU. Okay, so we can write, if you write a question why carbon used as a reference. So we can answer out it. First point is because it is widely used, it is widely used as standard in mass spectroscopy. Due to C12 has zero mass defect and its mass exactly 12 AMU. Okay, if we write the second point, if the AMU is the 1/16th the mass of an oxygen 16 atom, it would change their atomic weight by 275 ppm. And if the AMU 1/12th the mass of a carbon 12 would lead to the only 12 ppm change, which seemed a valid reason. So this point we can consider if the AMU, which is atomic mass unit, or we can say this is the reference mass. So AMU 1/16th MU 1/16th the mass of an oxygen, the mass and oxygen 16, the mass oxygen 16 atom it would change their atomic weight by 275 ppm, and if the AMU (1/12th) thus mass of a carbon 12 would be, we can say, would lead to only 42 ppm change with seemed within reason. Okay, means if we use the reference 1/16 of the mass of oxygen 16, it would change their atomic weight by 275 ppm, and if we used 1/12 of carbon 12, it would lead the change only 42 ppm. So that is the means error is less here. If we talk the next third point, so third point based on their natural abundance, so we can write the natural abundance of most stable isotope C12 is 98.89%, which greater than the abundance of C13 or C14 atoms. Means the stable isotope of C12 is approx 99% abundance, and the rest of isotopes are present in very less amount, and C14 present in traces amount. That's why we can use it in carbon dating for the calculations of age determinations, age of fossils. Next, if we talk the fourth point, why we used carbon as a reference, so we can write if carbon 12 used, so it was suitable for, so C12 was suitable for all the elements to calculate their integer mass. Okay, so these are the major 4 points. First point, it have zero mass defect. Second point, if carbon 12 used, the change in atomic mass will be less. Third point is natural abundance of carbon is very high. Then it's another isotopes. And fourth point is if we use C12, so it will suitable for all the elements to calculate their integer masses. Okay, so these are the reasons why we use the carbon as a reference element, and continue to till today we are using carbon as a reference element. Okay.